All right, example 8. Finding displacement and distance traveled. A particle moves in a plane with a velocity vector given by what you see there. At t equals 0, the particle is at the point 1, 5. Find the position of the particle at t equals 4. What is the total distance traveled by the particle from t equals 0 to t equals 4? So, quite a few things to do on this problem. We'll start with the position of the particle at t equals 4 now. Hopefully you remember the derivative of position is velocity, so going backwards, the integral of velocity is position, and that's why this displacement works out, because it's a change of position. So let's find the displacement of the particle at t equals 4, and then we'll add it to whatever the original is. So let's start out with the integral from 0 to 4. Alright, so we've got this function here. We're going to take the integral. Now, I'm working this one out by hand, but again, as I've told you many times, if you don't want to work them out by hand, if you want to work them out by calculator, that's fine. Understanding, of course, if you take the AP exam, there may be a problem where you have to work it out by hand. But the antiderivative of t is t squared over 2. The antiderivative of cosine is sine, but you have to do u substitution here. U would equal pi t, which means that du would end up being a pi dt. So I'd have to add a pi, which also means when I was doing my integral, I'd need a 1 over pi, and so that's why that goes away. Similar process over here, and then of course the integral of 2t is t squared. Now we're ready to plug in our numbers, which we do here. You see a big long string of numbers. You can pause the video now if you want to look at all those, but I'm going to continue on. And the displacement ends up being 8/16. Now, what does that give me? Well, remember at time 0 I was at 1, 5, and then I moved 8 horizontally and I moved 16 vertically, so now my new position is 9/21. The total distance traveled, again, is the first squared plus the second squared. We're doing, remember, the magnitude, a squared plus b squared radical from 0 to 4. And I'm not even going to try and solve that one by hand. It would just be ridiculous. So we'd solve that one by calculator, and we get 33.533. So we moved a total distance of 33.533, and we moved from this spot here up to this spot right here. Alright, sketch the graph of the position of the particle in example 8 as it travels from 1, 5 to 9/21. Now, just a reminder, our particle was given right here. There's the velocity of it. But we want to sketch the position, so I need the position one. So we start out with this. Remember, this is velocity. Velocity is derivative. I want position, so I take the antiderivative, which I did on the previous problem. That gives me position. Now, having taken the antiderivative, we need to find out what the c value is. So I plug in what it gives me. It tells me at t equals 0, remember at t equals 0, the horizontal was 1. So at t equals 0, the horizontal value is 1. And now I can simplify that out, and when you do that, you get a c value of 1. So c equals 1. Likewise, this is my velocity vertical component. So I'll take the antiderivative, which I did on the previous slide. I have this. Again, I've got to get my c value. At t equals 0, the c value is 5. Now cosine of 0 is 1. So I'll subtract that 1 over there, and I have a c value of 4. Now, ladies and gentlemen, you can use your parametric graphing to sketch this graph right here. And when you do, it ends up looking like that. So you see quite the crazy. It comes over here, loops around, back and forth, and it ends up going in that wild direction. And that, ladies and gentlemen, is all for today. If you have any questions, bring them to class tomorrow.